Hello everyone, welcome to All About Analytics. In previous tutorial we have learned a measure of central tendency for each class. In this tutorial what we have to learn is we will fill the missing values using Scikit's simple imputer class, right? So let's start it. How we can do that? First of all, you have to import these libraries, the pandas, matplotlib, then import your train and testing data, right? Here this is my train data set. What I'm doing is I'm doing this in a small letters so it will be easy for me to, right? This is my train data and this is my test data. Okay, now let's check for train test data set, train.head, right? These are the first 5 rows of train data set and these are the first 5 rows of test data set. Now if you see that my train data set is having 81 columns and test data set is having 80 columns, right? So train data set is having one column extra, which is our target column, or you can say that is our target variable. So what I will do is I will make two variables named as x train and y train. Okay, and then in x train what I will do is I will delete this sale price and store all these other columns inside x train, and inside y train what I will do is I will store the sale price column only, right? So let's do that. First of all, create x underscore train, okay, equal to inside that train dot drop underscore columns columns equal to which column you want to drop. I wanted to drop sale price, right? Okay, now let's create y underscore train, in which I wanted to add this column train sale price, right? So we have successfully splitted and added sale price in different variables, right? So now what we have to do is we have to import our libraries. So over here from Scikit-Learn dot import simple imputer. Right. So we have successfully imported the simple imputer class. So if you wanted to see the official documentation of simple imputer class of Scikit-Learn library Scikit, so this is the link, and here you can read all the parameters which are used inside that class. Okay, and you will see these examples how to perform all these things, right? And what kind of methods we have to use inside them, like fit underscore transform, get parameters, set parameters, transform. Okay, so let's get back to our tutorial. In this, now as we have splitted all these sale price column, now what we have to do is we will impute first numerical columns, then we will impute then categorical columns. Okay, so let's select the numerical columns first. Okay, so num underscore var equal to train equal to x underscore train dot select underscore d types include equal to int 64 comma float 64, right? dot columns. I want those columns names, right? So this will give us the column names of those. Now what I wanted to check is, I wanted to check that numerical values variables, that how many numerical variables having missing values, right? So we will do it like this: x underscore train numerical variable dot s null dot sum. So there are three variables which are having missing values: this one, and this one, right? So we are having only three variables in which our data is missing. So let's impute the mean values inside them. I'm imputing mean values. You can impute median also, or whatever you wanted to impute. Okay, you can, instead of mean or median, you can use your constant value in case if you wanted to use any constant value, like any number you wanted to impute. For example, if you wanted replace nn values with 0, so you can use that also. Okay, so I'm using imputer underscore mean equal to, let's call our class simple imputer, right? Inside this I am using strategy means which value you wanted to impute, right? So I wanted to impute mean value. Instead of mean you can write median, mode, or constant, right? Constant, in case if you wanted to write constant, right, just write constant and give your value. And now we are ready to impute mean value. So let's impute this mean value inside numerical variables. Imputer underscore mean dot fit function for doing for fitting the mean value inside the numerical variables. We will use this function dot fit function, right? X underscore train num underscore var. Okay, so it is successfully executed. So in case if you wanted to know that for example, if you wanted to check that which numerical variable have got which value, which mean value, right, which column has got which mean value, so we will do it like this: imputer underscore mean, right? Now you use this argument dot statistics underscore. So these are the, see, we was having it, how many columns we were having? Numerical 3 columns, right? But all it is showing the missing values for all the columns. For first column the mean value is 7, for second column the mean value is 5.68, for third column this is the mean value, right? And so this is the way it is giving us values of each column, right? Now these mean values are not imputed yet in our data set, so for imputing them we have to call transform function, right? So we will do it like this: imputer underscore mean dot transform. Inside transform function we have to give our data set x underscore train, which data set we wanted to transform now. So we wanted to transform numerical variables num underscore var. So let's execute this. So as you can see, this is giving the output in numpy array, right, not in data frame. So let's convert this numpy array into a data frame. So how? So I'm directly imputing this inside our data set. So x underscore train underscore var equal to, what I'm doing is I'm copying this, Control C, and paste it here. Simple. Imputer underscore mean dot transform, and in this way you can simply and directly impute your values. Now do the same for the test dataset also, because this was only for training dataset. Now we have to impute our test dataset also. So the same mean value which we was getting in our trained dataset, we will impute the same mean value inside our test dataset also. So num underscore var equal to imputer underscore mean dot transform x underscore test, sorry, not x underscore test, it will use test because I was using test dataset now. Test num underscore var. X underscore test is not defined. Oh, wait a minute, just give me a minute. Actually I'm doing it wrong. This is the correct way, because x underscore test was not a variable now. I have declared it as a test variable, not x underscore test. If you see there, here it is test. Okay, so our test data set is also imputed now at this time, right? So let's go to our next step. Now we will check for the missing value if any missing value is present in our x train and test data set, right? So x underscore train dot is null, sorry, not x underscore, in this way I'm doing is num underscore var dot is null dot sum. So as you can see, there are 0 missing values, all the missing values are cleaned. And over here let's check it for test dataset. Test num underscore var dot is null dot sum. So as you can see, our test dataset is also clean, right? Now let's do it. Now let's impute our categorical variables. These were the numerical variables which we have imputed. Now let's do it for categorical variables also. So what I'm doing is I'm just copying the above code. Wait a minute, this one. I'm just copying this code, Control C, because it will take a lot of time. Num underscore var. So I'm writing here cat underscore var, and in data type I'm selecting object instead of float 64, right? Not columns, right? Now let's run it. Now x underscore train. Now what we have to do is we have to follow the same procedure as we did for numerical variables. So same procedure I'm doing it for categorical variables. X underscore train cat underscore var dot is null dot sum. This will tell us how many missing values are having inside categorical variables. So as you can see, there are 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 columns were there which are having missing values, right? So what I'm going to do is inside when I have told you in previous tutorials also, when it comes to categorical variables, we have to impute the mode values, right? In case of categorical variables, we impute mode values. Okay, So let's do this. Imputer underscore mode equals, let's call our class simple imputer strategy equal to what we want, most frequent, or you can write most frequent or mode also, right? Most frequent, right? You can write most frequent or you can also write mode, both are same. Now let's fit this imputer underscore mode dot fit. We are fitting the mode value inside which data frame x underscore train cat underscore where, right? Run. Mean, median, most underscore frequent. Actually this was most underscore frequent. Okay, so in this way our mode values are fitted inside our xtrain cat variable. Okay, now what we will do is we will check the stats that which column has got which mode value, right? So doing that, what you have to do is imputer underscore mode dot actually leave that. What I'm doing is I'm directly imputer underscore mode, because I've already told you how you can check that, so not repeating the same thing is not, is a wastage of time. Imputer underscore mode dot transform, we'll call the transform function. Inside the transform function, what I'm doing is x underscore train cat underscore where. I'm directly imputing the missing values for here. Imputer dot under imputer underscore mode dot transform test under cat underscore variables, right? Right. Now what we have to do, we have to do same for the test dataset also. Imputer underscore mode dot transform test cat underscore where. We have to impute our test variables also, right? So I imputed this also for our test dataset. Test underscore, this is our test dataset, right? Test equal to cat underscore where, and this one I did for x underscore train cat underscore where, right? So missing value imputation is done over here, and if you run this, so you can directly check that our code is working correctly. Now let's check for the missing values, if any, present inside our categorical variables. So x underscore train cat underscore where dot is null dot sum. You can check. So as you can see, no missing value is present inside this, right? All the 14 or 15 columns which were having missing values are neutralized. Okay, so let's check it for the test dataset also. Test cat underscore where dot is null. dot sum. So you can see that our test data set has also been all those NaN values has been removed, and this is also cleaned, and this is also cleaned. So in this way we can use simple imputer, okay, to clean our data set, okay. But this method is not always effective when we perform data cleaning, because in this way, if we, for example, suppose if we wanted to impute mean values in these three columns, and in these three columns we wanted to impute median values, and in some columns we wanted to impute mode values, okay. So this simple imputer class cannot do that, okay. For doing that, what we have to do is, in that case, we have to create data pipelines, which we will learn in the next tutorials, okay. So till that, thank you so much for watching. Thank you.